If you are studying for the KCNA exam, you need to understand the difference between containers and virtual machines. Because this is one of those topics that looks simple, until the exam gives you two answers that both sound right. So we are going to dive deeper into the difference between a virtual machine and container. A virtual machine runs a full operating system. A container packages an application and its dependencies, but shares the host operating system kernel. That is the big difference. Don't worry, that sounds more technical than it really is. In this quick bite, we're going to break down containers versus virtual machines, why both exist, how they are different, and what you need to remember for the KCNA exam. Welcome to QuickBytes Education. Today's quick bite is all about containers versus virtual machines, explained simply, quickly, and clearly. Let's get started. A virtual machine, or VM, is a software-based computer that runs on top of physical hardware. A VM has its own operating system, its own kernel, its own libraries, and its own applications. For example, you could have one physical server running multiple virtual machines. One VM might run Ubuntu Linux. Another VM might run Windows Server. Another VM might run Red Hat Enterprise Linux. Each one behaves like a separate computer. This is possible because of a hypervisor. A hypervisor is the software layer that creates and manages virtual machines. For the KCNA exam, remember this. Virtual machines virtualize hardware. Each VM includes a full guest operating system. A container is a lightweight, isolated environment used to run an application. A container packages the application code with the dependencies it needs, such as libraries, runtime components, tools, and configuration. But here is the key difference. A container does not include its own full operating system kernel. Instead, containers share the host operating system kernel. That makes containers much lighter than virtual machines. Think of a VM like renting a full house. You get your own kitchen, bathroom, utilities, walls, roof, everything. A container is more like renting an apartment in a well-managed building. You have your own space, but you share the building's core infrastructure. And yes, in IT, even our apartment examples somehow turn into architecture diagrams. The biggest difference is what gets virtualized. Virtual machines virtualize hardware. Containers virtualize at the operating system level. A VM needs a full operating system for each virtual machine. A container shares the host OS kernel and runs as an isolated process. That difference affects resource usage, startup time, portability, and isolation. VMs are usually heavier because each VM includes a full operating system. Containers are usually lighter because they share the host kernel. VMs usually take longer to start. Containers usually start much faster. VMs provide strong isolation because each VM has its own operating system. Containers provide process-level isolation, but they share the host kernel. So here is the simple exam version. Virtual machines are heavier but provide strong separation. Containers are lighter, faster, and easier to scale for cloud-native applications. Let's say you have a web application. With virtual machines, you might create several VMs. Each VM gets an operating system. Then you install the application, libraries, runtime, security patches, and configuration on each VM. That works, but it can take more time and use more resources. With containers, you package the application and its dependencies into a container image. Then you run containers from that image. The container does not need a full operating system of its own. It uses the host system's kernel while keeping the application environment isolated. That makes containers faster to start and easier to move between environments. This is why containers are popular in DevOps, CI/CD, microservices, and Kubernetes. For the KCNA exam, this part matters a lot. Kubernetes is designed to orchestrate containers. That means Kubernetes helps deploy, run, scale, connect, and recover containerized applications. In Kubernetes, containers run inside pods. A pod is the smallest deployable unit in Kubernetes. Most beginner examples show one container inside one pod, but a pod can contain more than one container when those containers need to work closely together. So the relationship looks like this. A container image is the package. A container is the running instance. A pod is the Kubernetes object that runs one or more containers. Kubernetes manages pods across worker nodes. That is the flow you want to understand. Here is where people sometimes get confused. Containers and virtual machines are not enemies. They are often used together. In many cloud environments, Kubernetes worker nodes are actually virtual machines. Then containers run inside pods on those worker nodes. So the stack might look like this. Physical hardware at the bottom, a hypervisor above that. Virtual machines running as worker nodes. Kubernetes managing the cluster. Pods running on the worker nodes. Containers running inside the pods. So no, containers do not always replace virtual machines. In real-world cloud environments, containers often run on top of virtual machines. That is a very important point. Virtual machines are useful when you need a full operating system. They are also useful when you need strong isolation, support for different operating systems, or legacy applications that were built to run on traditional servers. For example, if you need to run a Windows workload and a Linux workload on the same physical hardware, VMS can help. VMS are also common in enterprise data centers and cloud infrastructure. Containers are useful when you want speed, portability, and scalability. They are great for cloud-native applications, microservices, automated deployments, and environments where applications need to move consistently from development to testing to production. Containers also work well with CI/CD pipelines because teams can build an image, test it, and deploy the same image across environments. That helps reduce the classic problem. It worked on my machine, which, as we all know, is not exactly comforting when production is on fire. Let's clear up a few common mistakes. Mistake number 1, saying containers are the same as virtual machines. They are not. VMS virtualize hardware and include a full guest operating system. Containers share the host kernel and isolate application processes. Mistake number 2, saying containers have no operating system at all. Be careful with that wording. Container images can include operating system user space files and libraries, but containers do not include their own separate OS kernel like a VM does. Mistake number 3, thinking Kubernetes runs virtual machines by default. Kubernetes is mainly used to orchestrate containers, although containers may run on worker nodes that are virtual machines. Mistake number 4, thinking Docker, containers, and Kubernetes are all the same thing. Docker is a platform for building and running containers. A container is the packaged application environment. Kubernetes is the orchestration platform that manages containerized workloads. For the KCNA exam, remember these key points. A virtual machine includes a full guest operating system. A container shares the host OS kernel. Virtual machines virtualize hardware. Containers virtualize at the operating system level. VMs are heavier and usually slower to start. Containers are lighter and usually faster to start. VMs provide strong isolation. Containers provide lightweight process isolation. Containers are commonly used for cloud-native applications. Kubernetes orchestrates containers by running them inside pods. And in real cloud environments, containers often run on virtual machines. So, containers versus virtual machines. A virtual machine is like a full computer running in software, with its own operating system and kernel. A container is a lightweight application environment that shares the host OS kernel. VMs are great for full OS isolation and traditional workloads. Containers are great for portability, speed, scalability, and cloud-native application delivery. And for Kubernetes, the key exam point is this. Kubernetes manages containerized workloads, and those containers run inside pods. In one sentence, virtual machines virtualize hardware, while containers package applications using operating system-level isolation. Like, subscribe, and keep building your knowledge with QuickBytes Education, one QuickByte at a time.